We're going to look at solving using trig identities, and first one we're going to do is by squaring. Now when you square both sides here, why we want to do that is because when I square this both sides, I have tangent and secant, but when I square secant, I could switch that tangent, and by switching that tangent, then I only have one trig function that I have to solve here. So and when you square both sides, you got to watch out because you might add extraneous solutions, which are just extra answers. So you got to make sure that once you get your answers, if you square both sides, that you plug those back into the original and see if they work or not, right? Because you might have answers that don't work. Those are called extraneous solutions. So when we square both sides, this becomes a quadratic, so we get tan squared x plus 2 root 3 tan x, because I take tan times tan, right? Because this is tan x plus root 3 times tan x root 3. That's what the squared means, right? So I take tan times root 3, that's a root 3 tan, and then another root 3 times tan, that's 2 root 3 tans together, and then root 3 times root 3, which is positive 3, and this is secant squared x. Then I can go ahead and switch this to 1 plus tan squared x, and so then we can subtract tan squared x on both sides, and hey, those cancel out. That's kind of nice. So then just get 2 root 3 times tan x plus 3 equals 1. Then we can subtract 3 on both sides. So we subtract 3 on both sides, and we get 2 root 3 tan x equals negative 2. Divided by 2 root 3, divided by 2 root 3. Looks like those 2's will cancel out, right? Because we got a 2 on top, and on bottom we're multiplying 2 times root 3. So those 2's will cancel out there. And we'll just get a negative 1 over root 3, which can be rationalized to root 3 over 3, and it's a negative, so we're looking what angle gives us a root 3 over 3. Well, that's a pi sixth, right? But I want to use that as a reference angle because my answer is negative, and tangent's negative up here and down here. So if I add pi 6, if I go back pi 6 from pi, that would be a 5 pi 6. And then if I go down from 2 pi, I get 11 pi 6. You could also do this in degrees as well, 30. So it'd be 150 and 330. All right, then I need to check these, right? So I have tan x, which is root 3, negative root, or tan x, which is 5 pi 6. That's my x, right? That's my angle, and that's just going to give me a negative root 3 over 3. And then I'm going to add root 3, which is the same as adding 3 root 3 over 3. So we get 2 root 3 over 3. But then on the right side, we have secant of x. Well, secant of x deals with cosine, and cosine of 5 pi 6 is root 3 over 2. So this is root 3 over 2. And since we're in the second quadrant here, this is going to be negative. And then we can flip that. So that's cosine. This is cosine, so I have to flip it, right? So that gives me 2 over root 3, which is a 2 root 3 over 3, but it's negative. So these do not compute, right? This has a negative, this is positive. So that 5 pi 6 is not going to work. We can plug in 11 pi 6. On this one, we know we're going to get the same answer because it's tangent. All right, so it's going to be negative, still negative root 3. But over here, when I put an 11, my cosine is going to be positive, so this will be positive, so then it is true, so this one does work. Okay, so here are some, oh, not that one. Okay, so here are not really steps, just kind of like guidelines of what you can look for when you're solving trig equations. Decide which form you want to do, or which form it looks like, and try that method first. Then if there's only one trig function, get that by itself before you look for the angle. Then if there's more than one trig function, try to maybe set one side equal to 0 so that you can go ahead and then factor it, or maybe then set each of those factors equal to 0. If you have a quadratic form, then factor it using the quadratic formula or CAB, and then setting those equal to 0, and then finding your angles from there. Last thing is you can try to square both sides. You might have to use some identities, kind of like we did in the last example. So then, but make sure if you square both sides that you check for those extraneous solutions or extra answers. So here we go on page 696, number 41. Okay, so here's number 41. So you can use those kind of guidelines to solve this one, right? We're probably going to square it because that's what we did in our example. And then so probably move one thing to one side and then square both sides, and then go ahead and use an identity, substitute it back in. Okay, so I'm going to get one trig function to one side. So I got cotangent of theta equals 3 minus 2 cosecant of theta. I can go ahead and square both sides. I'm introducing extraneous solutions, so I need to make sure that I go back and I check my answers when I'm done. Oh, so that becomes 9. This becomes negative 12 cosecant of theta, and this becomes positive 4 cosecant of theta squared. So this time when I switch cotangent to cosecant squared of theta minus 1, then those like the example actually is not going to cancel out the squareds, right? So we're going to have to do a quadratic formula or CAB. Hopefully CAB will work, right? Because quadratic formula with these is a little more complicated. So this is 10, this is negative 12 cosecant of theta, and then plus 3 cosecant squared of theta. Okay, so we'll try to do CAB. So that's 30. My B is negative 12, so I have to think what times what is 30, but adds, right, to 12. So that's 6 and 5, that's 30 and 10. Ooh, 15. Wish that was negative, that would be nice. Okay, so can't CAB it, that's not going to work. So we can do Pythagorean, or not Pythagorean theorem, quadratic formula. So negative b, that's positive 12, plus or minus square root of b squared is 144, and then minus 4 times a is negative 12. Negative 12 times our c is negative 120. Subtract those, we get 24. We can reduce that to 12 plus or minus 2 roots 2 times square root 6 all over 6. We can reduce these. These all have a 2 in it, so we can reduce those. So we get cosecant of theta is equal to 6 plus or minus root 6 over 3. Okay, and then so when we do this, I'm gonna do this on my calculator. So I do that on my calculator, and I get theta, not theta is equal to, still cosecant of theta is equal to, let's do just 2.8. Okay, and then so. And then I can do the second one, I can do the minus. So now I'm going to do the minus. And so here I get 1.2. And now this is cosecant, so if I flip that to sine, that'd be 1 over 2.8. And this would be sine of theta equals 1 over 1.2. And so then I'm going to do the reciprocal of these. Sine inverse of 1 over 2.8. And so I do that, and then I do sine inverse of 1 over 1.2. And so here for this one, I get 20.9 degrees, and this one, by 1.2, I get 56 degrees, or 0.4 degrees. The careful thing here is I probably should have kept in 0.28 and blah 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 over, kept this answer and didn't round yet. I want to round till the very end. And then when I plug these back in, they actually both kind of, this one will be really close, this one will be off, so this is actually not the correct answer, but this one is, and it's more like 57, but we'll go with 56.4, but in the back of the book it has 57. And then if you balance that, so sine, my answer is for sine, where I get a positive answer, right? It balances over this 90 degrees, right? So if I'm at 56.4, then this offset to 90, and then if I offset that same amount on this side, I'll also have an answer that is the same as this 56.4. So I do that, and I get so I'm going to take that 56.4 and I'm going to subtract 90 from that, and that will give me 33 something, so the distance 33. So then I'm going to take 90 and add that 33 to it. and then that will give me 123. So the other one is also 123 point, we'll say 6 degrees. And so those are actually my two answers there. And in the back of the book, it's 57 point something, and then probably 124 or something like that, where your answers are kind of similar. Pretty close to 56 to 57 in the other one as well. So if we would have kept those numbers in there in the back of the book, they have 57.7 degrees. So that will work for this one if I would have kept these decimals in there, right? And then to balance it, is I just add, I don't actually go this way, because this is just up 57 degrees to this point. So if I go up 57 of this, so if I take 180 and I actually just minus, so take 180 and minus, hold on just a second. So the other one is using, I think, off this 20.9 and using that 20.9 and then subtracting that from 180. So take 180 and subtract the 20.9, and that's where they get the second answer of 159. So not using that because 159.